Previously we spoke about net force, and all the net force is just the different forces that are acting upon an object. So that could be some of the things that we've learned about so far, gravity, the normal force, friction, and applied force. By the way, it's just the sum of the forces acting on an object. We discussed it when we talked about Newton's first law. Now Newton's first law states that an object that is at rest, or an object that is in motion, will maintain that motion and direction as long as the net force is equal to 0. But what if we have an unbalanced force? Well, that's when you actually start to talk about Newton's second law, which, expressed mathematically, is force equals ma equals ma, where force is the net force, and it's written in units of newtons. M is the mass of the object, which is written in kilograms, and A, the acceleration of the object, is expressed as meters per second squared. Now I just want to explain what these parts are though. So if we look at a box I have, and I push on the box, moving in this direction, just disregard mass for just a second. When I apply a force to this, the box's acceleration will increase and move in the same direction as the box. What's kind of interesting though is if I take that box and I increase the amount of force on it, the acceleration will also increase. Now let's look at this same thing with mass though. So if I push a 10 kilogram box with a certain amount of force, we'll say 10 newtons, it's going to accelerate, just like we stated before. However, if I take that same force that I said, which was 10 newtons, and I apply it on an object that has a larger mass, say 50 kilograms, it's going to accelerate, but it's going to accelerate slower. John is going to explain why this is next.
Now we're going to look at how we can manipulate the formula F equals ma to find an object's mass and its acceleration. To find the mass of an object, using this formula, you take the net force and you divide it by the object's acceleration. You find the mass. To find the acceleration on the object, you do pretty much the exact opposite. You take the net force and you divide it by the object's mass and you get the acceleration. Showing that acceleration and mass are inversely proportional to each other. If you take it over here, you can look and see that the larger an object and the smaller an object, the larger object will move slower compared to the smaller object based on the same amount of force being applied.